All right, today we're going to be talking about lesson 6 called scientific notation. Now, scientific notation is really, really important for numbers that are really, really big or numbers that are really, really small. And we'll talk about what those look like. So, scientific notation is written in this kind of form. We have a number times 10 raised to an exponent. The number out front here, a, has to be a single-digit number. So this has to be a single-digit number. A different way to write it is it has to be greater than or equal to 1 and less than 10. So it can be 1, but 10 is not a one-digit number. What you can have here, so for example, this is going to be a decimal value. This is a decimal value. And it has to be a single-digit number before the decimal point. For example, A could be 3.6, 2.8, 7.248. Could be numbers like that. The number in front of the decimal point cannot be a double-digit number. So you cannot have 11.6. We would have to have it be a single-digit number before the decimal point. Now, the nice thing is the exponent can be any integer. Remember, an integer is a number. So an integer is a number with no fractions or decimals, and it can be positive or negative. It can be positive or negative. So negative 6 will work, positive 17 will work, negative 32 will work. All of those numbers are fine because those are integers. Now, if we have a number written in scientific notation, first of all, this here is written correctly. It's a single-digit number before the decimal point multiplied by a power, or with a 10 raised to an integer exponent. So this exponent tells us how many times to move the decimal point. Because right now, scientific notation, this number is going to be pretty big, and scientific notation allows us to write a big number in a smaller fashion. So scientific notation, we can convert back to standard form. Standard form means that there isn't any kind of power of 10 multiplied behind it. And how we do that is we base it off of the exponent. So the exponent tells us, again, how many times or how many places to move the decimal point. If the decimal is positive. So if the decimal is positive, or if the exponent is positive, sorry. If the exponent is positive, the decimal moves to the right. So in this direction. If the exponent is negative, the decimal moves to the left in that direction. So if we were to convert 3.5 times 10 to the 6th, the exponent tells us it's 6 places. It's positive, so it moves 6 places to the right. So I'm going to write down the factor, which is what this number is called. This is called the factor. 6 places is the exponent So we go 1 place, 2, 3, 4, 5, 6. So the decimal point is now right here. I have all these extra spaces, so I fill them all in with zeros. So 3.5 times 10 to the 6th is 3,500,000, or 3,500,000. The decimal point was right here, so I moved it 1 place, 2, 3, 4, 5, 6 places. So now the decimal point is after this 0. The exponent does not tell us how many zeros we add at the end. That is not true. The exponent simply tells us how many places to move. So, example 1, 9.62 times 10 to the 5th. The exponent is 5, so we move it 5 places. The exponent is positive, so we move it to the right. So 9.62 moves 1, 2, 3, 4, 5. Fill in those last places with zeros, so it's 962,000, 962,000. Example 2. 2.85 times 10 to the negative 5th. The exponent is 5, so I move it 5 places. Negative, so to the left. So here's 1, 2, 3, 4, 5. Fill in, here's the decimal point, fill in all those empty spaces with zeros. So I have 0.1234 zeros, 2, 8, 5. Now, converting standard form to scientific notation is a little bit more tricky because it works kind of in the opposite direction of what we would think. So, there's a couple steps. The first step is we want to move the decimal point until a 1-digit number is in front of it. So, for example, the decimal point is right here right now. If I move this direction, I'm not getting smaller. I'm getting bigger. In fact, there are more numbers in front of it. I'm adding more digits in front of the decimal point. So I need to move in this direction. So 1, 2, 3, 4. I now have a 1-digit number, which is 3, in front of the decimal point. So now I have 3.5. The next part is we add a power of 10. So we're going to do add or times 10. With an exponent that matches the number of places moved. So it moved 1 place, 2 places, 3 places, 4 places, 5 places. So this is going to be 3.5 times 10 to the 5th. And then the last thing that we have to do is we have to determine whether that exponent is positive or negative. So exponent is positive if number, the original number, this 350,000, is large, essentially what I mean by large is more than 1 digit before the decimal. And it's negative if small. What I mean by small is less than 1 digit, essentially a 0 before the decimal. So this number was large. It had more than 1 digit before the decimal point. So this is going to be a positive exponent. All right, let's do some practice converting those. So 931,500,000. First step, move the decimal point until there's 1 digit before the decimal point, right here. So I have 9.315. Second step, add a power of 10 with an exponent that matches the number of places. So 1, 2, 3, 4, 5, 6, 7, 8. Last part. Is there more than 1 digit before the decimal point at the beginning? Yes, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. So this is a positive. Example 4. Move the decimal point until I get a 1-digit number beforehand. Here it is, 4. So 4.4. Add a power of 10 with the number of places to match the exponent. So 1, 2, 3. This number had a 0 in front of the decimal point, so this has to be a negative exponent. All right, last part of this lesson here, comparing and ordering numbers in scientific notation. So when we compare and order numbers, it's kind of like we're doing it alphabetically. The only problem is the first thing we look at isn't the first letter. First thing we look at is the exponent. Larger exponent means larger number, and smaller exponent means a smaller number. So that's the first thing we look at. We want to order them based on their exponents. Second thing we look at is the factor. Remember, that's that number out front of the power of 10. Same thing. Larger factor means larger number. Smaller factor means smaller number. So larger factor means larger number. Smaller factor means smaller number. All right, example 5. It says order these colors from least to greatest. So first thing we have to look at is the exponent. Larger exponent means larger, smaller exponent means smaller. We're going to look at these. Those are all the same exponent. So we can't use those to help us order because they're all the same. So now we need to move on to the factor. Larger factor means larger, smaller factor means smaller number. So since we're going from least to greatest, I want to look at the smallest factor out front. So 6.7, 6.1, so 6.1 is smaller. 5.1 is smaller than that. 3.8 is smaller than that, but 7.5 is larger. So red is the first number. It has the slowest or the least frequency. So red is first. I'm not going to cross that one off to know that I did that one. Next one is this 5.1, so that's orange. Next one is green, then blue, and then violet. And that is the color order from least to greatest frequency. All right, that is the end of the lesson. If you have any questions, please let me know.